So as a company, we're a software provider, but also an outsourcing service. So really, I thought, well, how do we look as if how we've had to change as a company to meet clients, I would say, digital construction needs from ourselves. So you don't really need to know. I'm a structural engineer who likes to play with software, so I've already crossed over to the dark side. So, as a company, CADS, we're based in Dorset. One of the big things really about how we work with digital construction is we have 500 technical staff. We've got detailers in India who are producing 2,000 A1 drawings a month. So we do a lot of work in India for what we do in the UK. So when we start to talk about BIM and digital construction and off-site manufacturing, a lot of this information will be coming through us through third parties. We started in 1969, jumping through really. In 1996, we are now global. So we've got offices in London, India, USA and Dubai. So USA is one of our biggest sort of areas as well. Software solutions, we started off as obviously being a software provider, so a lot of these sort of things for engineering, civil and structural. Smart Engineers is like a desktop calculation package, individual designs. 3D Max, sort of 3D analysis, first order, second order analysis, P Delta, and I mean a lot of other sort of tools that we look at. We're even moving into more app-based products now, so we're continuing to develop apps. So we've got retaining wall designers, glass designer, a new Valventi, like a wind designer. So we're actually still advancing our needs for the market. We work with a lot of manufacturers. So with the manufacturers, you can see we've just got a few there that sort of link into our products. So again, the emphasis on us is to make sure if we start to look in a digital environment that we're actually including these people and getting that information into our products. We also, and this is very critical for digital construction, we've got partnerships. So the one partnership we've got at the moment is with I can't even say them, Bluebell. The idea of this, especially with digital engineering, is linking BIM models to analysis. So you're running analysis models, information come back into the BIM model. We've sort of spoke about it a bit today, this disjointed method of a BIM model and something else comes in. Analytical models now being linked into Revit models, so all the information's in one place. And we're even coming up with solutions to work within that BIM model now for structural engineering. This, obviously, as you can see here, covers timber frames, CLT panels, glass and aluminium design. So everything that you can design can be actually put into this platform, then transferred into a BIM model. So these partnerships are critical for us. Again, nonlinear analysis might be lost on a lot of people. One big thing here is CAD's footfall analysis. Footfall analysis is that we're even developing things now to add in to these third-party packages. We specialise in this, so we've actually said, look, you can use this in your... So footfall's becoming more critical now for even things such as stairs. So designing things for footfall analysis. It used to be just for bridges, but now it's coming more, and hospitals, but it's becoming more response factors. Again, a lot of sort of standard products and projects that you can work with, FE analysis and these sort of things. Now, one of the main products for CADS is CADS RC. And this is an AutoCAD-based platform. And what this really did was take 2D drawing to the next level. It allowed, AutoCAD's great. The best thing about AutoCAD is you can draw anything. The worst thing about AutoCAD is you can draw anything. So the idea of this was to actually start putting macros into Drive and sort of like design parameters. But the idea is to pull information out. We can even then start to design to codes in AutoCAD. AutoCAD isn't intelligent. A line's got a length. After that, it's got a line style. So by actually building these macros into the software and all this information allowed us to drive forward. So these are the sort of drawings you can sort of, I mean, these are automated drawings as well. So you move something here, it's schedule updates. This is an AutoCAD. So again, it's this automated processing a lot of BIM requires. We've even now moved on to CADS RC 3D for Revit. So again, we're bringing that technology and that information and that sort of process into a 3D environment. Now, this isn't, well, the idea of this isn't new to Revit. Revit can put reinforcement in, but if you ask a lot of people in the industry, do you use Revit for reinforcement? They'll say no. I say, why? It's just because it doesn't give us the tools we need. So what we've done is provide the tools you need to come up with solutions. And again, as you can see, standard BIM model, these are the sort of things that we were talking earlier with Alistair and linking into BIM projects and all these sorts of things. But one of the main things we do is outsourcing. Clients will come to us. We've got a lot of big clients who are working on a lot of big projects in London, and they will come to us and say, we're working on a BIM project now. We used to use you for 2D drawings, but now we're taking the step into BIM. Can you provide us with this? So as a company, we've had to evolve and develop new ways of working to actually meet our client demand. So my standpoint today is really coming from a third-party standpoint. What have we had to do differently to meet digital construction, DfMA? So it's these sorts of things. Reinforced concrete is obviously 2D design, and it says there 78% still produce 2D drawings. Problem with a 2D drawing, if you're not using CADS RC, is it's just a line. You can't get any information from it. BIM is about the eye, it's information. What information is involved in that rebar? So the benefits, I mean, these are quite standard benefits. I think this applies to every BIM project if you're using everything. So again, construction issues can be viewed in 3D, clashes, accurate scheduling. You change the length of a bar, it updates your schedule. You change your design, your analysis will tell you it's out of date, and you might not have enough rebar. You can call it out or show in red. This isn't correct. So we're preventing these problems. Prefabrication, again, we'll show this in a minute. Valued added products, so we can actually include couplers, manufacturers' couplers into the product to enable connections quicker on site. And waste reduction, a bit of a difficult one there, but with waste reduction, the idea is to cut steel if you're cutting on site and use it elsewhere. So again, you wouldn't know otherwise. You just have to take a guess at it. So before manual or computer-aided design, we have manual detailing. Now I've just put a little asterisk next to these prone to manual error if you're doing standard drawing, and the reason for it is the argument is that if you ever, and probably many of you never drew on a drawing board, is if you did, you probably took more time on a drawing board. With computer-aided design, it's easy to draw something and then move it afterwards. But the idea of this is all manual. Revisions, long-winded process, open to interpretation, guesswork, standard rules. So again, doesn't lend itself well to modern methods of construction. So when we start to look at CADS RC for 2D, the idea of this is accurate bar bending schedules. You change something, it'll revise the bar bending schedule. It's automating a 2D process. It is linked to BIM in some platforms with level 2, as long as the digital, even if it's a 2D drawing, is called out and then linked back in. So it's got a circle of references. It can be classed as level 2 BIM. Output to fabrication systems. This is the big one. The idea of this really is in that CAD drawing using CADS RC with that schedule, it's got a length. Every bar has got a length and a number and a quantity. The idea of that then, it can be sent straight to machining. Machines then can cut the bars to length based on that schedule. It comes straight out the software, straight into the factory. It's in a data file, a CSV file. There's lots of different sorts of platforms we use. They can be cut and bundled with tags. They know where on site they're going. You can even put GPS coordinates if you wanted onto the elements, so they know where to put them on site. And it also lends itself to other fabrication methods, roll-out mats. So again, this can all be done in a manufacturing process. Now this is still 2D. So again, with that CADS RC putting the information into the elements, we can call it all back out into manufacturing. We've got a simple case study. I'm not going to go over it too much, but the idea here is at the last minute we changed from light gauge steel, the client did, over to concrete. They still had to meet the schedule. We had enough resources to put it all on, 400 drawings created, and it delivered on time. So we've got those sorts of resources. Any changes were automatically updated. so we could actually manage and run the project. Now, when we come to 3D Revit modelling, this is really where BIM and digital construction comes in. The idea here then is that we're working with the client's Revit model. They will send us their model. It's a digital model that we will pick up. We will then detail it, design it, do whatever we need to do to it, create schedules. We can then link it to design. So again, that partnership with Rebar, we can actually send it out to that, do the analysis, bring it back. It can do minimum requirements for area of steel. So we can do all these checks before we even get to site. We can also output to these fabrication systems we saw earlier. And again, obviously, we're going to reduce rebar wasted costs. So again, that sort of lends itself to the side there. It's 60% saving on wastage and costs on site. From that then, these can accurately be sent into fabrication factories. We can put lifting eyes, we can put in the correct locations, make sure the stresses aren't going to be too much, straight from the 3D model. Any changes, update schedules, and that gets then sent to the production line. Reinforcement and BIM coordination. So this is a big thing. This is where a lot of our larger clients wanted our models. With 2D, you can't do this. So in a 3D environment, we can start to look at rebar, how we start to place it, where we place it. Will it clash with something else? Will the bars actually fit? So it's a coarse industry in the fact that you might go to site and see a guy with a crowbar moving things into place. But the idea is that's great if it's touching each other. But if there's a base plate that's coming through and hitting it, will it cause a problem once it's set? These sort of things are what we're going to look at. What it also does, it lends itself for digital construction in coordination. So this is BIM 360. Somebody can pick it up straight away and review it on an iPad on the way home. That's a Surface Book. They can actually do it on a phone, get your model, we've uploaded it. Oh, I want to have a look at it. Yeah, we're not going to use those couplers on this job. That then is automatically portrayed back into the model. Now, this is the information that our design service are having to do. We could be working on a huge project and the guy sat over in the UK could pick it up, look at it, mark that up. The guy in India picks up the model, looks at it, says, okay, that's the note, we'll change that. All on that model. Without having paperwork, the digital trail can be tracked. So it goes back, we know we've sent it. So we can sort of get around these. These are a couple of videos, and the idea of them, I think the second one takes way too long to, but the idea of them is that the first one is sort of with an iPad, and he looks around the iPad, and it's sort of the model on an iPad, it's sort of a hollow view, and sees where a pipe's coming through to see if it'll work. The second one is just placed on site to see if it clashes with anything. And what it is a site compound, so where they've got to move things because they're already seeing the next stage of delivery of rebar to site. So, tools for coordination. Now, as a software house, we've sort of had to step our game up by creating these 3D tools. Now, the 3D tools in Revit were really for us as a company to use. We use them for our design service. But then people started to say, will you make them commercial? Can we use them? So what we've even started to do now, again, with this link to analysis, we've even started bringing analysis results. We've even created built-in tools now to mark up areas, what we call schematic reinforcement. So an engineer would usually pick up an FE map, draw over it with marker pens, scan it back into a computer and send it over to a client. The idea of this is with very limited knowledge of Revit, an engineer can pick up an FE map of the moments or the reinforcement, or as they say, deflections in a slab, place reinforcement without even having to go outside Revit. So it's all in one digital model. So all the information's in one place. So these are tools that we're creating ourselves to allow this process to be sort of automated and in one part. We're even to the point now where within Revit, we can use our tools to place rebar. From rebar then, we've got automated drawings, so these assembly drawings. Those assembly drawings then using things such as PXML and Unitech, you can actually then take it out to a manufacturing slab. So again, this is manufactured off-site. And then the last image there is actually, again, BIM 360. Somebody investigating the whole thing. And that's all just from the Revit model, one model. We've even gone into, can't say the name of the company, but we work very close, and we've even developed tools within Revit for Twinwall. So again, these are two concrete leaves that are held together with a ladder, that then concrete gets poured on site. It's all done off-site, again, assembly drawings, lifting eyes, rod eyes, and all these sorts of things. So again, this is all, again, what we've done to try and bring everything together and do everything within one environment. Now, this is where we're sort of looking for how we're moving forward. So you've got your Revit model with all the rebar. The steelwork underneath was created in Inventor, and all they did was just said fill underneath and created then a shape that was CNC machined and folded in suit, cast, and then lifted on site. So they say they saved about 3 months on site just from doing this within a controlled environment. And they used that then for, I think it was 4 bases. Now, future of where we are. So if we're looking at the future, SketchUp model, reinforcement done, could be automated, but the idea is it's a 3D printed reinforcement. So it lends itself, what we were talking to, a 3D printed concrete. So these sort of practices are taking place. Now this is even taking it further, and again, linked earlier to robotics and robots. That's actually tying the reinforcement. So there's no working at height rules, there's nothing. All it's doing is following the path, tying the reinforcement as it goes. It can even bend and shape it as it needs. So it's again showing how this sort of technology is now linking into environments that we sort of wouldn't expect it to. I flew through it. We've caught up. We might even make lunch. 1:45. Okay, so like I said, it links coarsely to what we're going through today, but the idea is to show how we've had to adapt to meet our clients' need for digital construction. And we're finding more off-site manufacturing now that we're doing, especially with so prefabricated panels and twin walls and these sort of things. Okay, is there any questions? I doubt it. Okay.
Well, thank you very much,
thank you.
Jason, for that
No
great
problem.
technical insight. Thank you.